Welcome friends. Today we will see about the hard disk data structure. How the data is stored in the hard disk. What are the platter, what the heads, about this detail we will show you today. That is an understanding hard disk data structure, first chapter. First of all we will explain all those things in the structure. What is there inside the hard disk? When we open the top cover, you will find this type of items, this type of materials you will find. In center, it is a spindle motor which rotate the platter. The platter are fit with the help of screws inside the platter. Here you can see the three platters are there. Between that there is a spacer ringer, three platters. So here is a normally 6 head, top bottom like this. Here is an activator axis, activator arm, and here is your head is here, slider head. Actuator head, actuator magnet is there. SATA specify connections are there. So you can check all those things here. Magnet, logic board, PCB, and all those things is the internal parts. Next. First of all, we will go the logic part, that is a PCB. PCB we already have seen these things. This is the PCB main components. Here is a power connection, protection, switching. Then it will go to the motor rotation, and here is the data signals comes. Data signals come from here and onwards like that. So this is your hard disk block diagrams, PCB. Next, inside the hard disk, when we open the hard disk, inside there is a platter. You can see the platter. Platter will be look like this. This is your platter, big platter or small platter, 2.5 or 1.5, depend on that you can see the platters. This is a aluminum platters. The platters, hard disk has a one or more platter or disk, and each platter usually has a head on each of its sides. Modern drive platters are made from glass or ceramic. So you can listen the voice. This is ceramic or glass or aluminum like that. The platter themselves are non-magnetic but have a magnetic core which holds the magnetic impulse which represent the data. In one side it may be 1 TB, 2 TB, depend on that storage it can store the data. In every drive all the platter are physically connected together on the common central spindle to form a single assembly. Means all the platters are connected like this step by step, and in between there is a spacer ringer. Like this spacer ringer will be there, and it will be connected with the motor. Like this it will be connected with the spindle motor which rotate the platter like this. And here will be one head, and here will be one head. Here may be one head, here one be head. Like this work will be there. Normally here is a how many head? 6 head and 3 platters are there. Like this work will be there. This is basically functions. So in every drive you can find this type of process are there. If there is in some hard disk we will find 5 platters, 1 2 3 4 5. So how many head? You can check a head maybe like this. We will see here how many heads are there. You can count it. How many heads are there? So you can count. There is a 3 platter set, and top bottom there is an head. You can check the head in between. It will be look like this. See. Okay. In this is 1 head, 2 head. This is 3 head, 4 head, like this. The platters on side there is a head. You can check head like this. Okay. Next, the platter are kept apart using the spacer ringers that fit over the spindle motor. Entire assembly secures from top using the cap or cover. There is a cap and cover will be there. Each platter has a two surface that are capable of reading and write the data. Now what is an platter surface? Platter surface are look like this. This is your platter. It has an micrometer size, but in this layer you will find a lubricant layer. First 1 nm nanometer is lubricant, 15 nanometer is a carbon overcoat, magnetic layer 30 nm, chondro layer and an NIP sublayer, meta sublayer, like this layers are there. To lubricant carbon, magnetic, aluminum reflection, rigid metal layer, protection layer. So these are the layers you can found in between this plater. This is your plater, and small size will increase like this, you can see. Okay, so there are the PMI structure. There is a carbon core overcoated, excite, growth, seed layer, soft magnetic, head anti, that is a PMR layer. So there is different type of layers are there. Now what is the work of read write head? To read write head distance, we have to measure what is a 1 meter is equal to 0.001 milli. 0.000001 is a micro, nano and pico meter. So the read write head floats on the cushion of air only the nanometer. Nano means middle distance is like this. The surface of the plater. As the read write head pass over the spinning plater, they magnetize the surface in the plater which represent the data in the form. See, you can see the distance. Here is a very less distance and this is your plater. The plater store the magnetic field like south to north or north to south, 0110 There is two type of recording method, longitude and perpendicular. Okay, there is a two type of soft underlay. It will be, before that they are using this type of technology, and now it is perpendicular stand up positions. There is two head, one is for reading and one is for writing. Writing required the coil winding, and reading only it will read it is north or south, like that the heads are there, head tops. It read and write. Reading what is there, it read the data and give the image, and then it will go ahead to write the pulse. We will write the pulse and he will change the location of north south like that. Next, what is the distance between the head and plater? This is a head 0.0005 inch. This is your head plater and this is a head. These two, there is the smoke particle is this much, fingerprints is this much, and dust particle this much, and human hair is 0.003 inch. The human hair, you can see the black hair, it is this hair, its size is like this. If you zoom it, dust article will be like this, fingerprint will be like this, and smoke article will be this. So distance is only this. So you cannot remove the plater and do any task on the other sides. So this is important, why we have to work on the clean room, because we require the clean room to work, then only it will be success. Otherwise when the dust flow on the plater, then it cannot go below the head and it will work on the head like that. It is also important. You can see the dust, you cannot see with the eye about the dust. You can see on the microscope the dust particles. Next, spindle motor has a different type of coil like this, and it has a magnetic coil like a fan. The coil gives the current, so motor is spinning like this. You can check here. Here is a coil. These are the coil, and the top cover is like this. This is a old motor. So it is a top cover will look like this, and when the power come in the three coil, they are the AC coil. So when one coil on, it starts spinning, then one off, then second on, then third on, like that cycles is going on, and plater are clapped here only with the help of spacering. So this is your motor. The plater are mounted on the spindle motor which turned by the drive motor. Older hard disks typically spin up 3600 rpm, but new motors were working on this much rpm. Okay, modern hard drive can transfer 80 megabytes data per second, like that. Lot of noise. So these are the normal. So spindle motor also have some reliability. Spindle motor must provide a stable, reliable, consistent turning power. Thousands of on off triggering will be there. It has to manage the speed. Motor must be high quality, so 1000 of tolerance start and stop cycle. It must be smoothy and with the minimum of vibration, not too much vibrator, otherwise the head will damage. Heat created by the cylinder motor can be eventually cause damage to the hard disk, which is why we never the attention paid to their cooling, because if motor is hot then the problem will be there. All the hard disk spindle motor are configured for direct connection, no belt, nothing is there, it is directly connection into the motor. Next, see, this is motor base, stator core, ring magnet, rotor, hub, seal, like this function. Another is a head arm. This is our head arm. You have seen this is a head arm, head actuator and head arm, all complete sets are there. Here you can see one IC is there, small IC is there, which control the motor signals. You can check, here is a small IC. Okay, I will give you a snapshot later on. The triangle shape head arm, this is your head arm, this is arm, this is head, and this here is your actually slider or head. This is a bearing, this is back side, there is a coil which rotate head from left right like that. Here is a coil, you can see the voice coil, bearing, all those things, and the belt are there which connect the motors. Next, head actuator, this is your head actuator which rotate left right, so head will go here and come here like that, the head actuator. Read write head types, there are different type of head types. Old, there is a MIG, metal in gap, thin film, magneto resistance, AMR head, 1990, GMR, then 1997, then TMR, that is 2004. Then nowadays it coming perpendicular magnetic recording, and after PMR their SMR is coming, singlet magnetic recording, and hammer HMR recording. This type of recordings are head type of coming. Okay, this is a ferrite head, this is metal in gap and thin film. These are the head type you can use. Magneto resistance head, magneto is also there, this is magneto, and GMR, giant magneto resistance, TMR tunneling hammer, and PMR perpendicular magnetic field recording, and SMR drive. New helium drive, you can see this type of helium drive which can open with the help of drill machine. Without drill machine you cannot open the HLR. Hammer hard disk. Okay, these are the new hard disk. Perpendicular magnetic, 2 dimension magnetic recording, singlet, microwave assistance, heat assistance magnetic recording, bit pattern media, like that. Next, air filter is there which filter the circulate air. It is on the this way, when the air come it will go through from inside and come outside, so the filter of the air, circulate air will be filtered from here. Now how the plater store the data? Suppose we have 80 kg box and we want to put the 10 kg weight on it, the rest 790 kg we cannot allot any other, so we will make a partition of this box like that. So first 8 row like this we have make a road, 8 row we have count. Now one row also take 100 kg, that is also very big, so we will divide each row with the help of column. So now one box contain 10 kg like that. So now if I put the 10 kg here, it use only this much, not all this utilize. So if I take this 10 kg here, then it will utilize this much, and we can give the address is like that, row 1 column 1. Others are free, we can use another row like that, another row we can use like this. So for this purpose we are using. So now we will give the address like this, row 1 column 1 I put this, row 2 column 2, here is what, row 1 column 2, like row 2 column 1 like that. These are the column 1, row 8 column 1, you can see like this we can give the address. So address is very different. So like this only we have gone on plater, like this, like a container we have one plater, very big plater. So platter are subdivided with the help of track, and track are subdivided with the help of sectors. Track is very big, so we have make one sectors like this. So track further divided into sectors. Okay. Now address are as below. Now we have to give the address to all the sectors. So we can identify where we have put the data. The one sectors is this. So these sectors look like this, small portions. It will be like this bit storage. Now how we will give the address to the each section? So we take example LBA, logical block addressing 0 to 64, and CHS addressing 0012, like that we can calculate. So any one starting point we go, this is your LBA, and it address is 001, 002, 003, 4, 5, 6, 7, 8, 9, like this we have given the address 16, 0016. So there is two type of addressing, that is one CHS, one LBA. What is a CHS? Cylinder, head and sector calculation. These three calculations are there. So here is your cylinder, head and sector calculation. This is your cylinder, this area is cylinder. Head means what? We can assume there is if I have two platters and I have one zero head here, one head here, two head is here, and three head is here, like that. So which portions, if you have two platters, then it is in bottom. So this is we are calling as a zero head, zero cylinder, zero head, and sector number 2. This is one sector, this is 2, like that it will calculate. If I put here, then what happen? It will count cylinder number 2, this is cylinder number 1, 0, 2, like that, 2, 0, 2, here, like this it will calculate like this. So this is your addressing like this, the CHS calculation. But every time we cannot use this CHS addressing. If I put any data ABC something, so it will not give me the location C0016. So they are making one address books. All this address 006, 00, suppose 0, like this, he will make one translator book. Translator, what he will do? He will put 001, its name is LBA is 0, like that. 002 is equal to 1, like that. 003 is equal to 2, like that he will give the LBA addressing. And when we note down any file, it will store the LBA address where it is stored. It is stored in 2, so it will note down here 2, like this. If I put data something here, then it will take location of 11 LBA. It will not give me the address like that 0, 0 and 12, like this it will not explain me. It defined that these file are here on LBA 11, like that. For that purpose we have two type of addressing, and mainly in data recovery these problems comes. What these problems comes? The address is wrong. So related to next address will not come. So next data it will not search. In this condition we have to regenerate the translator. So this is a case where we have to do this thing. So this is your address again. This is your new addressing 0, 1, 2, 3, 4, 5, 6, like that. LBA 0 to 265. Next. So this we have defined here. We give example here like this. Here we have given address 0. 0 is fixed. It is denoted by MBD, MBR, master boot record. You know already master boot record, which have an informations of partition and all those things in NTFS. And if GPT partition, then up to here it has located the GPT partition. Okay. Next. There is two type of addressing, LBA, and one more is a PBA, physical block address. Physical means manufacture time. At the time of manufacture, all the sectors given one address, that is a fixed address, that is a PBA. And when user use and regenerate the translator, then the new address come, that is a logical block addressing to the CHS. Suppose this 7 is my bad sectors. So here is my 7 is a bad sector. This sector cannot store any data. So what happened? After 6 it will go here, and it found that this sector he will try to read, so hard disk become a slow, and this is your bad sector. Okay, then bad sector, so my hard disk will stop working, or it will not go further, it will not go here. So in that condition we have to regenerate a translator which give the 8 number address as a 7 and 6 9 number like this. It will regenerate the address 8 9 like this, he will address again. That is a translator issues. So what is the work of translator? That is important. At the time of manufacture also some bad sectors are there, some sectors are bad at the time of manufacture. Then he will add this bad sector list in a one directory, that is a P list, permanent bad sector list, and he will skip this 13 and he will make his 14 15 like that. It will make an address like this. So this is one case. Next, so this I have given an address here 0 1 2 3 4 5 6 7 7 I have bad sectors, so it has been error 8 9 10 11 12 13 14 like that. From here to here it has given some address, sorry, from here to here it has given to the C drive. This from this to this, sorry, it has given to D drive. From here to here it has given to E drive like that. And this is your last. There will be a more than above something sectors will be there. If there is a 1 TB hard disk, approximately 1 TB hard disk, then it has in sectors from 1953525 this much sectors are there. This much addressings will be there in 1 TB hard disk size of, it is up to here 33, but this n is equal to what? It will be this much 1953525 this much sectors numbers will be there. So in these conditions it may be some sectors are on the top, some sectors may be bottom, like that. I have already explained you there is a 2 platter, then it is a 0 side, this is 1 side, this is 2 side, this is 3 side. We explain these only on the one side, that is 0, and we also show very big, but it is not big, it is very small portions are there, and track is also very small. 64 lines are there, and here is 1000 something cylinders will be there. Okay, next. So this is your MBR GPT partition, C drive, D drive like this. Next we will go further. So these are the platter. I already explained what is a platter, what is a track, what is a sectors. That is important. Now this we have already seen. One small portion we can say the sectors. A group of sector is equal to cluster, and cylinder means particular area from top to bottom. Whatever the area track come is called the cylinder. And this is your track number 1 2 3 whatever. So if you say second number cylinder means 0 or 1 number cylinder means 1 number cylinder, the head will come particular to here only from top to bottom like that. So this is your platter. This is a sector, track, cluster. One platter surface can hold 1 TB data, so it is very big. So it divided by the circle, that is also big. So track are subdivided in the sectors, and sectors are group called the cluster. It's simple way. Same thing we repeat again and again, so you understand the different byte, different method. When we create any file, yesterday we see, on the last chapter we see, if we save one character, it will take 1 bytes, but it store that space of 1 sectors. The here sectors are of 4K. New hard disk, there is 4K sectors. When we write a single character in notepad and save, then also that file contain 4K size. Original file size is 1 bytes, that is 1 character, but it occupies space on the hard disk 4K because it is taking one group of sectors, that is a 4K. So this is important. Next. Now what is a sectors? 0 or 1 is equal to 1 bits, binary digit, 8 bits is equal to 1 bytes, 1 bytes may be from 01100 like that. Normally 512 bytes is equal to 1 sector, smallest unit of data that can be read and write. Typically sectors are 512 in size, but other size included 104, 204808, 2048, 4096 are common. So this is our 512 1 bytes, maybe 512 or maybe 104096. If there is a 4K sectors, then it will be one sector will be 4K, but in older hard disk it may be 512 bytes. Each sectors have a data stored from here to here, but there is some synchronized marker which indicate which sector is this. Sector address, synchronized marker, ECC and intersect gap. Up to here our one sector is complete, here to here. Mainly data is 512, but additional some gaps will be there for each sectors to address. Suppose is sector number 159, so here is a sector address, it will be here 159 like that, then only it will understand that this is 159, this is 160 like this. So all the sectors will be like this. The sector include ID information which status information about the sectors. Synchronization field are used to internally by the controller to guide the read process. Okay, synchronized marker is important to give the address for the head to read and write. Data is the actual data. This is actual data, your 512 bytes. ECC error corrections is a error correcting code used to ensure the data integrity, the data is okay or not, that is from this ECC. Gaps are one or more spacer added as necessary to separate other area of the sectors or the providing time to controlling to process. So this is a gap mainly, in between two there is a gap. So this is a bits, bytes and sectors. Next, what is a cluster? Cluster is a smallest unit of disk space allocated for files and directory. File system do not allocate individual disk sectors. They allocate a group of sectors called a cluster. If 512 byte sectors, it will not take one by one. It make one group of 512 like this. This if it is 512, 1, 2, 3, 4, 5, 6, 8 512, then 8 512 is equal to 1 our cluster size. This is your cluster. The hard disk use 512 byte sector. A 512 bytes cluster contain one sector. 4 kilo cluster contain 8 sectors like that. Sector range from 1 to 512 to 128 sectors like that. Smaller unit space of the hard disk that any software can access the sector which normally contains 512. Each cluster has a fixed size that is always a multiplier of the sector, maybe 1248, but nowadays it work on 8 only, 4K. Now new hard disk more than 2 TB size are coming with the 4K sector size, which increase the size of the hard disk. You can see this is a 512, 512, 512, but every 512 there is an synchronized back and address are there. So they have removed these all 512 and make one 4K format. So this much space they have gained. This is 4K sectors work, 4K sectors. But before that there is 512, 512, 512, 512, 8 sector is equal to 1 4K. But now a new hard disk there is only 4K byte sectors are coming. What is a block? Block are the size of sectors. Block are sequence of the bytes. When the data structure is a blockade, blocking the process booting block. Okay. Track and sectors we already seen. This is a track, sector, cluster. Track, sector, cluster, same thing we have repeated here. Next, it will address like this: sector 0, sector 1, track 0, sector 2, like that it will give the address. Older time that cluster size is very big, FAT16. Now NTFS greater than 2 GB hard disk, it will be 4K cluster is fixed. Like this you have seen the platter, head 0 may be count from top or bottom. The one platter has 2 head like this, 2, 2, 2, and it will read from here to onwards. If there is only one platter, then 2 head, 2 platters, then 4 head, or 3 platter means 6 head, 5 head, 0 to 5. Now this will give the address like this, what we have seen in the LBS CHS calculation will be like this. This is the LBS CHS calculation. 001 inside 101 201, and here it goes C cylinder 0 outside, 8 number 2 and sector number 1, like that he can give address. Okay, that is a CHS calculation. We can count also like this: 1024 cylinder into 328 into 63 sector is equal to number of sector 2064 sectors. 2064 into 512 is equal to 1.05. Like that, the size of the hard disk we can mention. Sometimes zone bit recording also there. If you make all the partition like this, then it will be problem. So here is a zone bit recording. Every zone they have different sector size. This is your summary. You can see my doc file from the website. You will find out some question answer also there. You have to clear the question answer. Thank you. This is chapter 3 over. Now we will go on chapter 4.